obviously we want random numbers between 0.1, so that translates into 0.28. And we put that in our formula, we'll read off the graph, and we get travel time of 88.4. That means that it comes back at time 113.4. And again, we're keeping a track of the loader and the vehicles, how long they wait. Well, obviously they both started together at time 0, they went straight in, and so on. All the other columns are the same as before. You know, cycle number 1, cycle 1, vehicles 1, 2, 3, 4, start loading, load time, finish loading. Load time, yeah. Arrive at loader, start loading, load time, finish loading, random number, travel time, arrive back at loader, etc. So obviously that 113.4 is the time that that translates itself down to there. 113.4. That's right. I hit the edge of the table. So it comes back down to 113.4. And then we go on to the next simulation. We generate a random number 89. Calculate the travel time. Obviously, it's a high number relative going near to 1, so the travel time will be nearer 110 than anything else. So 106.7, that will come back at 156. And obviously, in this case, the vehicle, I put it in brackets again because this is a startup effect. The vehicle queued for 25 minutes, but I'd say it's a notional thing because obviously you've got to start somewhere in every simulation. That's why it's in brackets. Then we do another random number, another travel time, another random number, travel time. And these values, 113.4, the 156.7, 174, 189, have all come down from the first run, and then the rest of the runs have all been completed each on the sheet. So we're able to do a simulation. And you can see now, just by varying one thing, one element of the whole process, which is the travel time, we've now got in this case the loader waiting, in this case the forklift truck driver waiting, here are vehicles waiting, here are vehicles waiting, the vehicle waiting, the loader waiting. So it's changed the whole system. We've got a pattern now of vehicles and loader waiting and so on. And obviously if we ran the simulation long enough, we did enough cycles, we did 50 cycles or 100 cycles or something like that, we could average out the waiting time of the vehicles, we could average out the waiting time of the loader and so on. And obviously find out what's going to happen in our simulation if we vary the travel time. Now obviously, as I said, we've got another element in here, which is the load time, and we could add another column in before E with some random numbers. We could have a probability distribution function that describes loading times. We could simulate the load times. All it would do would then give us, is rather than having 25s down here, they would be varying numbers depending on the simulation. And we could put the whole lot together, and we could get some waiting times for the loader and waiting times for the vehicles and average them out and work out what's going to happen. So I think with the simulation